I would like to invite Mr. Akshay from the industry side. I want to come to you first. Being from the industry, our country is facing so many challenges. Some of them we have already highlighted in the intro. Supply chain issues, charging infrastructure, battery manufacturing, and all these things are there. So, from an industry point of view, to kickstart this webinar, I wanted to know your inaugural comments on the challenges that we are facing at this point of time, from the overall industry point of view.
Per se, I mean, thank you. First of all, thank you, and good morning, everyone who are the panelists and also the participants to this webinar. Challenges per se are quite typical. I mean, one is the of course what we are trying to push for a more localization. So now the sourcing is a typical challenge which we see that with a lot of initiative what we have taken ourselves to how much we can do a backward integration to ensure the localization. But then when you are doing that backward integration, you also have a you also live with the limitations, right? You can't do 100% within yourself. However, I think in the journey, I mean, in this specifically this EV journey, where I am actively part of it in the various organization and various professional responsibilities. I see a lot of things are getting sorted out slowly and gradually. Last 6 year journey, I think many things has been settled, but I think still we have those typical challenges in terms of the charging plug and cable. Those are the typical things which are high valued. They constitute a good percentage of product bomb, and then those are still has to be locally sourced and manufacturing. So there is a challenge. There is a challenge typically still lies with switchgear items, right? And specifically the DC EV charger needs a very high valued switch gear. So switch gear dependency is there. Other than that, I mean, we are still in a tier two place where we have the factory which is Chhatrapati Sambhaji Nagar, which is around 250 kilometers from Pune. But the challenges there are again, the logistic is challenge, but those are very, I would say those are, typically gradually getting to be resolved. Uh, Rest, I think we have a very skilled manpower. We, although we are in a tier two city, but I think that is a good blessing what we have. We have a good R&D team, I think, which supports this manufacturing product and other development. So the challenges remains. I would say it is minute in a nature to supporting to the business. But yes, I think having those done, that the aspiration of that, Vikasit Bharat, and getting into that localization. So I think finally, if I have to connect these two, I still see there are certain challenges, but I think there is a industry quite a increased industry involvement, and everyone is trying to look at the opportunities, evaluating the opportunities. So I think the EV charger itself gives a lot of opportunity for many other MSME kind of entrepreneurship and manufacturing uh, products. So I think and people are coming up. The industry is responding very well. So it's matter of a time. I think as we grow in the segment, I think things will be well in place.
A bit of a continuation question, and want to put it slightly differently as well. EV, for all of us, it's a work in progress. From an industry point of view, I wanted to know the approach that the industry is taking towards the integration of motor platforms with the broader EV architecture, and especially in terms of drivetrain efficiency, thermal management, and all. Would like to know your perspective as you are also working on the charging side as well. So, would like to know your overall thought process on the developments that are happening in this regard.
Yes, I think, I mean, I would be more, I would give the perspective more from the EV charger, or, the kind of energy, whether it is a conversion or a distribution of energy per se, to ensure this, the EVs are charged, and they have that, a ratio of, end of the day, everything, we all evaluate everything in terms of the speed, right? So we are working typically towards the speed of a charging, which finally, that is what is a user experience, whosoever is using the charger. Then, of course, the efficiency part, the conversion efficiency as of now, when it comes to AC to DC, it is up to 94, 95%. But then, end of the day, it is not only the charger conversion, but at a charging station, we have to uh, consider that the round trip efficiency from the tapping point of a transformer to the the finally connected point of a EV. So I think that's a work, that's a good area to work. We are also trying to create a DC-DC platform, where from out of the conventionally power electronics, where AC to DC has a certain limitation on efficiency, but DC-DC are quite efficient. And being this opportunity in high voltage, I see that that is one area where we can work. So that also we are working. We are trying to build the DC architecture based EV charger, which can be then part of any uh, energy storage or a BESS kind of installation. Because now, having that opportunity, or the trend where the decentralization of energy storage is also happening in the industry, right? So there are small plants which are coming right from the home application to the bigger, the megawatt plant. So taking that opportunity, I think this DC-DC or a DC architecture base EV charger could, increase this round trip efficiency for the charging infrastructure, and we are working on it seriously.
Okay. So thank you. And I would like to direct my next question to Mr. Manoj Desai. Uh, Sir, Mr. Desai, ARA is into almost everything like research, development, testing, certification, standardization of norms, everything you are there. So, my question is more regarding the regulatory, from the regulatory side of it. What are the current regulatory hurdles for the locally developed EV motor platforms that you are facing? And what are the steps that you are taking to make the industry more efficient domestically, and to reduce our dependence as well on imports as well? So if you can elaborate a bit, that will be. Mr. Desai, you are not audible.
Yeah, sorry. Yeah, good morning, all, and thank you very much for inviting us. As you rightly mentioned, let me brief about the standardization procedure in India, so that the people who have joined, they will understand. So, though Bureau of Indian Standard (BIS) is our apex body of making standards, there is a special provision, and there are two apex level committees in India under the Central Motor Vehicle Rules, which try to formulate the standards for all EV components as well as electric vehicles. One is Central Motor Vehicle Rule Technical Standing Committee, which approves or notifies the standard, and another is called AISC, Automotive Indian Standards Committee, which is chaired by Director ARA. So these committees, along with participation from the industry, always try to make the standards which are technology agnostic, so that the component companies or vehicle OEMs, they should not face any any kind of hurdle to their new designs which they are bringing into to the market. The another important point for the Indian industry is our all the standards which we use for EVs, for EXL, for motors and controllers, those are at par with global regulations today. So what is being followed in European Union under United Nations Economic Commission of Europe, there is a committee called WP29. So whatever regulations or global technical regulation under 1998 agreement they formulate to harmonize worldwide standards. So we are at par with those requirements. Our standards has technical requirement which are being followed in EU, USA, China, Japan, South Korea, all these markets. So they are equivalent. Another important thing you will appreciate, because recently because of these issues created by China on export on certain rare earth magnets, a lot of industry players had to move to alternate sources. Like many of the companies keeping the same performance, they shifted to light rare earth magnets, and we as a test agency had a good collaboration working with them, evaluating their new platforms in a speed up manner to minimize the required testing if if they are retaining the performance with this alternate material technology. So what I want to stress is here is standards. There is no hurdle bringing a new technology. So irrespective of type of motor, irrespective control strategy they have implemented, irrespective of their design, our standards, we have kept it as a technology agnostic and neutral, and we continuously try to upgrade our facilities as well as build a special rigs to perform validation testing of these type of devices if the designs are being different. So it's a continuous effort with the help from ministry. We started in 2015 to establish certain facilities where we were knowing that many of the companies will be doing a localization in this area in terms of building the motors, in terms of building the inverter unit. So we started establishing test facilities right from 3 kilowatt, 10 kilowatt, 30 kilowatt up to 250 kilowatt. Recently, we are upgrading our facility up to 500 kilowatt motor test bed, and those are done in where we can test in a even a EXL where you can connect the load at the both the sides. So it is our always efforts to be in touch with industry and understand their requirements and ensure that the regulation and the standards and the procedure are in place, as well as those are done well in advance before the vehicles come into the market. And that is the efforts. We have given a lot of input to the various government scheme uh, such as PLI Auto, which incentivizes such localization, local manufacturing of the advanced automotive technology components, which involves motors, inverters, EXLs, transaxles, and we evaluate those for performance, its safety, its minimum CMVR requirement, and additional endurance requirement. Those the endurance is not part of the homologation, but to get the government benefit for localization, some additional steps are being added so as to ensure the better quality products are given to the OEM so that they can bring the vehicle. So this is our effort. So in per se, in short, there is no hurdle as such from regulatory point of view for bringing any new products into the market. I think, Mr. Jacob, you're mute.
You mentioned
Yeah.
about the light rare earth magnets and all, and in such cases where timely clearance and fast clearances are required, and also there are a lot of new technologies that we bring in, the OEMs bring in. So in such cases, what is the sort of time frame, or how faster would you like to adopt some technologies, keeping in mind the safety aspects as well? Uh, I would like to know, would be interested to know that first.
Yeah. So the one of the important aspect of these regulations is we work on a worst case kind of criteria. So if at all any delta changes are there with respect to earlier approval, because that is how the market is moving. Like the OEMs are coming today, they are doing certain approval with certain technology tomorrow or another 6 months' time, there are chances either because of these restrictions, there might be changing of the material, there might be miniature of the design. So test agencies always has added worst case criteria kind of conditions in the regulation, and we try to see what is the delta change. Based on that, certain worst case analysis is done, and then required performance or required safety standards are safety tests are worked out, and we perform those tests, and we try to extend their earlier design or earlier vehicle approval, what they have done with this delta change. So this kind of mechanism always helps to the industry to reduce the time. There are many companies who are proactively engaging test agency well in advance. Like for example, I will appreciate many of the bigger mainstream OEMs or even the startup companies. So as soon as their R&D or design, they start something, finding alternate solutions, they start engaging with test agency. This is things, these new things are coming, these are the data sheet, in this manner we are moving. Then we suggest them certain development test plan, or you can say pre-compliance kind of test activities. Either they can do it in their lab or they can do it with our labs, because we don't only do the certification, we engage with them in pre-compliance or development activity. And based on the result, we early come to the conclusion that okay, what additional requirement needs to be done at the time of the vehicle certification. So that in that anyway, it helps industry to shorten the time. So that's a
Okay, got
good initiative from the industry to early engaging with the test agency. Yeah.
it. Got it. Thank you, Mr. Desai. I will come back to with a fresh set of questions as well. So now I would like to go to Mr. Pandit. Mr. Pandit, uh, I want to know in detail from you about the new motor architectures like e-axles, and what inspired the your focus on e-axle platforms for indigenization, and what are the outcomes that you envision from this?
Thank you, Shine. Firstly, to have me over. Um, See, the Pravriti Product Accelerator is a sector agnostic product accelerator. So we are looking predominantly at boosting manufacturing in India. So we have around eight such cohorts in various sectors, in the pipeline. EV is one of them. EV cohort is a little different from the rest of the cohorts that we are looking at, because EV market is predominantly dependent on imports, be it motors or be it batteries or the cells for that matter, lithium cells for that matter, and some of the electronics that go into the car. So typically around 60 to 65% of the BOM bill of material is dependent on imports. So that being the case, and also there is some amount of technology dependence, meaning earlier the OEMs had their own R&D in IC engines, whereas none of them have a solid R&D base on EV or the motors and batteries. So they are dependent on imports. So and then they may not also have the capability and capacity to locally manufacture. So these are the complexities, and to add to that, these are regulated markets, right? Wherein ARA has to approve the roadworthiness of a vehicle that needs to go onto a road. So with these kind of scenarios, it becomes very apparent that all these agencies have to work with each other. So that's what we are trying to bring, that the confluence of working with the regulatory body, the subject matter experts from IAC, that's where Professor Deb and the rest of the researchers come into picture, and the industry partners like Akshay ji here. So we are working with all of them to create a conducive environment where we provide opportunities for industry partners to start their designs early on with like what Mr. Desai was mentioning, that they interact with the ARAI early on, so that the requirements capture the regulatory aspects, so that they don't have to rework later on. So then there is subject matter expert engagement, so that brings in the technology part of it, and we also bring in market and IP management from FSID. So it becomes a very good environment for industry partners to work on and then develop a successful product for the market.
Got it. You mentioned about the partnership side of it. That's one of the core focus of today's discussions as well. Um, So what would be the kind of partnerships that will be critical for the success of initiatives like this? And what will be the role of each of these segments, like the role of academia, the institutions, or the role of industry from their side, and also from the government side, the regulatory role and regulatory requirement that the industry needs for the growth of such initiatives.
Perfect. So I'll go in sequence. So you've asked me quite a few questions there. So let me start with the market. So I mean, why do you make a product? You need to sell. You make money out of it, right? So we look at the market first, identify what products are in demand and how much are they in demand, who is buying it, so on and so forth. Then we identify what is the technology gap. In this case, there's a technology gap certainly on the battery side as well as on the traction motor side, but then we are addressing the traction motor now because battery is still a technology that needs to be settled because there are various competing technologies that are vying for space. So whereas the motor is something that has been around for a while, and then it doesn't need that much of a change in terms of research involved. So we are addressing the motor space. But then the challenge there is, one, we are dependent on raw materials, that is heavy rare earth and light rare earths in that perspective. And then also on the technology import, because we don't locally manufacture those kind of motors. We manufacture the conventional motors in India. Anything more than 6,000 RPM is not manufactured. Of course, the OEMs are trying to indigenize some of the assembly lines, but they are a work in progress. So now what we do is we bring the industry partners that are in the adjacent space and who are willing to get into this EV space as well, and then we connect them with the subject matter experts who help them with the technology, and the regulatory experts like Mr. Desai, who provide the regulatory aspects to it, and then we also provide market related inputs to them. So with all these information, it becomes very easy for the industry partners to develop those products and compete in the market. So to answer your second question on how and when they come in, so all of them would be stakeholders in the program, in the product development process, but their role changes at different stages of the product. So in the requirement gathering stage, where the industry partner connects with ARAI and the subject matter experts and the market experts to gather requirements for that particular market segment, to them, to be precise. And then once they get into the design phase, that's when the professors and subject matter experts come in, kick in their expertise. And ARAI becomes a monitoring agency where they monitor the design, review the design to see if they are good for the market. And then once the manufacturing kicks in, then the industry partner becomes the lead there. So they manufacture and then get it certified by ARAI again, and then go to market. So that's the sequence in which they operate.
Professor Dev, you mentioned about the design stage and the importance of design stage, and you are the design man here, and you look into the lightweight aspects as well of EVs. From you, Professor Dev, I would like to know about the key design considerations while developing an EV motor platform, because in India we have a lot of challenges, like in the case of our roads are difficult, rural roads are there, then climate conditions, each state has a different kind of scenario. So would like to know what will be the key design considerations when that you will look into while working on such technologies, considering all these aspects, Indian roads, as well as the economic efficiency as well. So would like to know from you, Professor Dev.
Yeah, sure. So first of all, I should thank the organizers for inviting me to this panel discussion, and also good morning to all my fellow panelists here. So this question is very appropriate for this discussion, I believe, because this is something that one doubt that I would like to clarify here, that when we are talking about this design of electric vehicles, it appears that, it is something which is completely a new sort of, product that we are coming up with, something which has never been probably looked at earlier. But actually what is happening in my opinion is that the overall approach to designing an electric vehicle is more or less is quite same as that of a conventional, IC engine based vehicle. So actually, when we are trying to design a vehicle, we do not think initially directly in terms of the modules or the hardware. So we think of the entire vehicle as an entity, and we set targets for designing the vehicle in terms of what we call as attributes. So when we say as attributes, I mean, it is not very difficult to understand, but this is a knowledge which I should say is quite restricted to automotive industry. So I should say that, when I am talking from academia, the reason that I am able to give this perspective, in my opinion, is also because I have previously worked in automotive industry. So drawing from my experience of having earlier worked in some of the companies like, say, Ford Motor Company in USA. And my first job was, of course, with Tata Motors, erstwhile telco. Drawing from this, real world exposure to vehicle design, what I'm trying to tell you is that there are these attributes such as aesthetics or styling, the designing of the appearance of a vehicle, and then packaging and ergonomics, and then there is aerodynamics. Then these are the three attributes which come very early in vehicle design. And so the targets for designing a vehicle are really set in terms of these attributes. So when we are doing this, nowhere we are saying that whether we are designing an electric vehicle or an IC engine based vehicle, that consideration comes later. And then what happens is we are designing a vehicle for, say, other very important functional attributes, such as NVH, means noise, vibration, and harshness, durability, that means for fatigue life of, various systems and subsystems in a vehicle. Then there is vehicle dynamics. And then, of course, there are a number of such attributes. I'm just trying to mention some of the more prominent ones. And then we have something called as crash safety. So we lay down the targets in terms of these attributes, and then we start designing the vehicle so that such targets can be met. And in this context, we start coming up with the hardware. Means what kind of body can meet these, say, targets of safety, right? And what kind of acceleration and fuel economy or range that we are trying to come up with, or for which we have set targets, and how we can meet this. So now the powertrain also comes into picture. So automatically, when the actual approach to vehicle design doesn't change when we are trying to design electric vehicles. So when we are trying to design the powertrain to meet those other, attribute related targets, we are replacing the IC engine with electric motor. That is the major change. And of course, now we need to have power electronics in terms of controllers. And if it is a battery powered electric vehicle or a plug-in electric vehicle, we need to have sufficient battery or onboard energy storage. And then, of course, if we want to replace the IC engine-based powertrain with this electric motor-based powertrain, then automatically things change now in terms of hardware. But the vehicle's performance and the expectations of a vehicle from the customer or the user, so those things don't change. So all these methodologies, and what are the criteria and requirements, these are more or less known. So you mentioned about these very challenging road conditions in India. I think for our OEMs, right? They are very well sort of equipped to design and test their electric vehicles to meet these challenging conditions. And I must tell you about one of my recent experiences in some of these wildlife sanctuaries and some, tourist attractions, where the conditions of roads were so, purposely they are made like that also to some extent, because in the natural conditions of forests and all that. And I saw how our Indian-made SUVs perform there. It is completely incredible. Only you have to have that experience to believe. I was always keeping my fingers crossed that the vehicle will stop now. Absolutely, it was a completely roller coaster ride in some of those old, Mahindra, Marshall, and all these Jeeps, etc. I mean, these are incredible workhorses, incredible machines. So I have complete faith that our OEMs will be able to deliver, electric vehicles to meet all these challenging India's. And I mean, such conditions exist everywhere.
Okay.
Only thing is that our main roads also sometimes are very unpredictable in nature. So I think, that way, I think it is not a major issue. The issue is with the new automotive companies, which are trying to fill in the gaps right now. Because what happens is the established OEMs, they have certain compulsions because of the way they are set up and their manufacturing processes and all those things which are already in place, right? So in order to come up with things which require different types of design, say, for example, lightweight design with newer materials, more usage of, say, lightweight metals such as aluminum, magnesium, etc. So when you try to come up with these new types of body architectures using newer materials also, the entire manufacturing process may have to change. And this is where an issue can arise with the established OEMs. It is just like, yes, sorry.
So, Professor Dev, I want to slightly interrupt you in between.
Yes,
You mentioned about the way OEMs are working, but traditionally, when you have you have experience with the Ford and Tata Motors, you mentioned.
yes,
Traditionally, when you look at Indian OEMs or Indian companies as a whole,
yes,
one criticism that we face is with the risks that we are not taking enough risk with regards to R&D side of it. And in EVs also, the import dependency in components is cited as one example of that. So
yes,
in the long run, when I understand that you look at the product as a whole, as a one entity. When you look at the future as a whole, then how should the OEM strategize their R&D and also simultaneously reduce their import dependence going ahead? Maybe
exactly.
2 minutes you can just give a
Sure.
brief of idea.
Again, I thank you very much for this excellent question. So right now, whatever I have told you, right, those were only the, the rosy side of the scenario, I told you. But there is an equally dark side also, which I should say in the Indian context. And I think it goes back to our maybe colonial era and our colonial mindset, right? Where we do not have the confidence to come up with things which can change the course of technology universally. So we are only trying to do things which others have already done and trying to become experts on those. But there is in my opinion, no matter how much we tell only the optimistic side of things that we are doing, I mean, we really need to improve our mindset, I should say, and try to become what actually in this in the area of product design in general, and particularly also in the area of vehicle design. So there are different objectives that companies set for themselves when they come up with vehicles or products. So one is like they want to be among the leaders, that is one goal that companies can set, or whether they want to become the leader, not just among the leaders, just for to become be ahead of the competition totally. So that is where Indian companies are totally missing out. So in my opinion, they do not invest enough in R&D to develop technologies which are completely new and which other companies don't have. And unless, in my opinion, we do this right, I think it applies to more or less to everybody in India. Because if you see, most of the Indian companies, they all started as joint ventures in the beginning. There are hardly any Indian companies, right, which actually developed their own technologies, and with that they have tried to conquer the world. I mean, unlike say many Western companies, German, British, American companies, etc., French companies also. So I think here we have to change our mindset, and we have the capability, no doubt, just that we do not have that self-belief.
Yes,
And I
exactly. Probably that self-belief is what something lacking at this point of time from our industry side of it.
it is.
I want to take this criticism to the industry representative here, Mr. Akshay. Mr. Akshay, would like to know, probably we have 3 minutes each for each of our panelists. Mr. Akshay would like to know your thoughts with regards to this criticism, and also at the same point of at the same time, since you are from the charging ecosystem side of it, uh, as a customer, I am still concerned about the range anxiety side and other infrastructure issues that a lot of the parts of the countries are seeing. So I want to know your quick thoughts. One with regards to R&D side and the role OEMs can play in co-developing standards and test protocols for next generation products and motor platforms and all these things, and also the from the consumer side about the range anxiety and ecosystem, how it is developing. A quick thoughts.
I think this has three parts. If I could understood your question rightfully. So one is of course the user who is ultimately to be benefited, right? For his experience, for his reduce anxiety towards the range, towards where is my charger, where I can charge. So I think this part of a thing is can be answered in two ways. One is a lot of thought process is evolving, and with this kind of a dynamic generation, I think a lot of things has been getting adopted as far as the user experience goes, right? So thing become a bit in a gray where one get convinced easily by charging the vehicle at a home, and one needs that in his own application. He needs that EV charging infra outside. So both the cases are both use cases in terms of a business uh, are there, and those are up to the person who has to get that confidence. Typically, if I have to give my own example, I had my first EV in 2019 when people just started talking about EV charging infra. But then, I think I did not face any problem. But yes, of course, everyone has the different usage, and that's thing. Now, the second part of your question, I think that's something which is industry should take up, which because other than that user experience, I think the biggest contributor is the power conversion. I think that is where the power electronics has a very high valued and proportionately high role to play. And that role is not only limited to having the technology, right? So the power electronics is something which has to it has a design, and then we as a country, I think we lack that experience of manufacturing of power electronics. So I think this put together could add a lot of value in terms of to the EV charger, or the different segment of a power electronics. Then power electronics has a huge application, and the way the energy storage coming in, I think that is also incomplete without a power electronics. So I think that plays a very vital role in the next level growth, bringing that cost efficiency, and even developing that technology. And then it would also add a value to the increased manufacturing abilities, right? And the manufacturing infra. So I think that's something which can be a very core point and point of a center for a lot of institutions where you deliberate, you create that platform, and then industry can pick up, or any other investor, if he is convinced, and then he can pick up, and that journey can be started. And the
Yeah.
third part is remain towards this the typically IoTs integration protocol. I think these are more evolved things now, because this is the one part where a lot of participation is there. I mean, that is really nowadays, if you given a choice between power electronics and IoT, I think a lot of people will try to choose IoT protocol integration as a first choice, right? So I think that is the trend. I think the trend has brought in the enough attention, enough the skill, enough interest of the people. So I think that is a sorted thing. But power electronics, critically out of these three, I think that is something to be taken to the next level of a task, and then involve the industry and evolve something around it.
Thank you, Mr. Akshay. And coming to Mr. Desai, I, I would like to know your thoughts with regards to the innovation scenario that is happening. We mentioned in detail about R&D and wanted to know from you from the regulatory point of view, do you think that there is a scope for regulatory sandboxes to accelerate innovation, basically in EV drivetrain platforms and also the need for innovations at this point of time to accelerate the entire EV mission?
Yeah, you rightly said we have done all this in past and we are ready to continue. One thing which I want to mention here, when initially in 2015 onwards, when the government came with the schemes to promote the e-mobility, what we did as an initiative is we formulated a separate AIS regulation specifically for those companies who want to bring the vehicles into the market or the components in the market for government scheme for pilot batch kind of thing. You can say it's a small series production. Just you want to try and assess the market instead of going for the entire homologation procedure. We allowed a limited, you can say limited set of tests and allow you to a limited quantity of vehicles and the components and assess the market. If suppose it could be established company or any startup company can take advantage of such kind of controlled environment, they can assess the market and see if the product is good and the market has accepted it, then they can convert that product in complete homologation. So it was, you can say, one effort which you can say it's a sandbox kind of a controlled environment, allowing with only a specific limited safety requirements to allow them to bring it to the market, test the market with limited number of vehicles, and then if they feel it is good working and there is a demand, then go for with the entire homologation activity. This we have done. Second thing you rightly mentioned, like such kind of things can be done as and when the new technologies are coming. It can be done at the component level also. But I would say the first step which we can do is this kind of experiment might be very easy or helpful for a pre-compliance kind of activity. So assume that you don't want to bring a final compliance product into the market, but you want to try something for a pre-compliance kind of activity, then based on the industry demand, such kind of activities can be always done, where a limited set of activities based on the new technology can be done, which gives a opportunity for any new company. Instead of investing time and money in full, they with that they can do the testing or validation or pre-compliance or development or mentoring activity. Even we try to bring the government ministries on the forum such that they can help through ARI if they are at particular technology readiness level to bring them to another level where they can go to the production. So it is being done continuously. We always try to ensure that various schemes of the government can be helpful. And past also for entire vehicle level, we have done a sandbox kind of thing, which allowed many companies to bring the product in the market to test it. And they have later converted it to the complete homologation. When they found that, okay, this is the right time, they can take their product based on the whatever data collected. But always while doing such kind of scenario, we have to be very careful, like ownership of the data, the IP coming out of that, what data or IP can go back to the fine tuning the regulatory requirement, how the permission should be given, ensuring minimum safety, ensuring the permission at a limited location or limited kind of scope. So such things we take care and build such sandboxes which helps industry to try their new ideas or innovative ideas, I would rather say, because the technology is changing so fast. It is not the older days where say 5 years or 7 years are required to bring any product. Nowadays the time has reduced a lot, By the time the OEMs bring something on the road, already the component or tier one might have migrated to advanced technology. So this kind of experiments are already done, and we always ensure that we help the industry to bring those innovative ideas in the market.
Before going quickly to other panelists, because a lot of companies here would be interested to know about that, how can startups and accelerators better engage with ARI with regards to the product development cycle? If you can give a quick view on this, that will be helpful for all the our participants.
Yeah. So quickly, I will tell there are two, three initiatives we have started with Ministry. One is the Technovus with Ministry of Heavy Industry, where we can bring the startups on those platforms where ARI can provide mentoring or helping them in their product development or pre-compliance, and certain schemes government has helped financially also through ARI for the selected projects. Then there is another initiative called AMTIP, through which also we bring these startups. We try to give a subsidized rates for any kind of pre-compliance development or compliance test activity wherever feasible, wherever possible. Third thing is we are doing satellite centers. We are trying in different cities so that we can go nearby the industry. So those may not be a full-fledged centers for considering all applications, but at least the segment where two and three wheelers are in more numbers, we can go in different cities and help these startups who need not travel all the way. So as I will just summarize, one is a Technovus initiative, one is a AMTIP initiative for getting the incentive benefit from the government, from ARI point of side, helping them or mentoring them from design side, validating their design as a pre-compliance activity, and if they meet all these requirements and they are confident enough they can go for the final homologation, then we help it. So this is how we plan, especially for startup companies who are new in these areas.
We have 6 more minutes before opening for an open discussion. Would like to know from Mr. Pandit with regards to how do we plan to balance the deep tech development with manufacturability and also supply chain readiness, and also with regards to the for the success of a cohort. Um, how would you like to take it forward beyond prototypes, like IP licensing and deployment? Would like to know answers on both these questions from you. On
Yeah.
one with regards to deep tech development first.
Perfect. So you'll have to give me a few minutes for that because it's a long answer.
Definitely.
I don't have a short answer for that.
Definitely.
But before that, I'll quickly tell that, drawing from what Professor Deb mentioned earlier, that, we are a country of, risk averseness, or maybe we don't want to take, I mean, it's a strong statement to make, but then it's a reality because if you look at the R&D investment numbers, we are around 0.68, 0.7% of the GDP, which is very, very low compared to a developed country, which is at anywhere between 3 to 6% of the GDP. So we look at, I mean, between us today and our Viksit Bharat of 2047, we see at least three hurdles. That is between the industry and their tapping of the full potential of the market. One is the mindset, that is, the risk taking mindset has to come in. Second is the risk capital investment itself that needs to be done. Today, the industry feels that they should get a product from manufactured by or developed by somebody else, and then they'll manufacture it and sell. But then they should also get into the mindset of developing their own products. And the third aspect is the skilling. You don't see a well-established R&D teams in any, even the major established industries. So that's something that they need to take care of. That they need to spend money on setting up teams that can develop new products for themselves. So we, I mean, though it is not something that we do as a transfer of technology or transfer of capability, we help them create these kind of opportunities. Like we help them set up teams, we help them understand technology and translate that technology into making a product. Now coming to your question on how do we balance it, so that's a TRL question. So typically when technology or an idea or a product concept is in its early stages. The technology level, readiness level is around 3 and 4. That's when it leaves the academia, right? And then once the industry wants to take care of it at maybe TRL 5 or TRL 7, if you TRL 7 to TRL 9, but then there is nobody handling it in between TRL 4 and TRL 7. So that's where we come in as a product accelerator. We involve also all stakeholders, including the industry partners and the academia, to walk through from that TRL 7 to TRL 4 to TRL 7. And then we also provide them all the possible ecosystem needs. Like, say, for example, they need a lab to test, or they need subject matter expertise from professors, or expertise from people like Mr. Desai from ARAI. So we provide all of that so that they take that technology from TRL 4 to TRL 7 and beyond to make a product. And for that, we have developed a process, a framework under our product accelerator, which takes care of all this. And then there is a streamlined product development process, which is nothing new. Most of the multinationals take their products through a process called new product development process. We have tweaked it for Indian requirements. And then we provide all those program management, product management, and even some amount of financial assistance to create that transfer, to make that possible, make the technology transference possible. That is translation from industry, academia to industry possible.
I would like to take one more minute of yours, since you highlighted the skilling part. Thank you for highlighting that. The industry is going through a transition with especially manufacturing, with AI coming in, automation, robotics, industry 4.0, and everything. So from the skilling point of view, would like to know your thoughts on how much of an addition or upskilling is required, or when you're coming into the industry, how should you work yourselves with regards to the changing technologies in the manufacturing sector in the EVs?
Very good question, Shane. Thank you for that. So upgradation is a continuous process. It doesn't stop. I mean, you ask anybody in the industry, they'll say that you need to keep abreast with whatever technology changes that happen. So what happens with our educational institutions, that is engineering colleges, is that there is always a lag compared to the industry's demands. So once they get into the industry, there's that catch up that need to happen. So that catch up is something that we help with. So we have focused programs as and when we create a cohort in a particular segment or a particular technology, we have a parallel track of skilling where we do VR, AR kind of skilling, where it is quite an involved practical way of imparting knowledge, where it is directly absorbed and applied in their industrial application. So we create those skilling programs which they can take advantage of. And as and when there is a requirement for an upgrade, they can approach us for that skilling, and then we will be happy to provide those skilling programs. And many of the industries are taking advantage of these skilling programs for their entry-level engineers, so that they become available for them for product development. So that's a trend that has started now, and then probably it will pick up much faster.
Professor Dev, coming to you, when we look at the innovation scenario, the lab scale, a lot of innovations are happening on the ground. That we hear a lot of things happening in the EV sector, a lot of new innovations, a lot of new technologies and ideas that are being introduced. However, when it comes to the commercial deployment of these ideas, India is somewhere lacking. Uh, I would like to know from a leading person who understands both the sectors, who worked with both the sectors, would like to know your thoughts in this regard.
So, sorry, there was this minor interruption while you were asking me the question. So, just I wanted
you want me to repeat that? You want me to repeat the questions?
No, I think I heard most of it. So I'm just seeking a clarification from you. So you are saying that how these lab scale, developments which are done in lab, how they can see the light of the day.
Yes, to a commercial, on a commercial large scale.
On a commercial basis. Yes. So I think there are different aspects, of first of all, I would like to say that many a time we think that whatever is done in academia in the form of, say, some concepts, physical concepts, or some type of tangible, solutions, they should always be commercialized. And if it is not commercialized, then it has been not a, successful effort at all. So here I would like to just tell you my viewpoint that academia sometimes has means different roles to play here. Its job, in my opinion, is not just to develop some innovations or technologies which can be commercialized. So here I give you some concrete examples quickly. So say, for example, once worked on I am not naming the OEM here, but once we worked on a project which had to do with development of methodologies. Are we?
Professor Dev, you are not
Uh,
audible. Can you? There seems to be some interruption in the network.
yeah, about this. Hear me? Am I audible?
Yeah, better. Yes.
It is better. I think, so in this age of very advanced technology, we still have some issues, limitations of technologies, so to say. So anyhow, what I was trying to tell you is that, sometimes, development of design methodologies can also be very helpful for companies trying to develop new vehicles such as EVs, or even for that matter, traditional vehicles also. So if we have, for example, come up with new or more reliable and robust simulation procedures, those could have been used for developing safer vehicles in a very effective and timely manner. So, say for example, there was some trickle down effect of what we have done in the past in terms of our research in these areas of improving crash simulation accuracy, which may have actually affected positively the performance of some Indian OEMs, such as Tata Nexon getting 5-star, in global NCAP, and now Mahindra SUVs also, such as 3XO, etc. So they have established themselves as leaders in these areas of, crash safety of vehicles, and similarly in optimization. So here also we worked extensively in multidisciplinary design optimization, and we have actually done projects with some of the established OEMs, and we were able to pass on these technologies to them. Now, so that is one aspect where there is a subtle contribution of academia, which is not very visible, and people don't realize this. So I just thought of pointing this out to you quickly. But apart from this, we are also many a time other academic groups also, I'm sure, are doing this at component levels, trying to develop, say, some motors which are better or have some new features in them as compared to the motors which are already there. Now, how do you get this into the market? That is one question that, of course, arises. So I think here, we have to be mindful of the fact that whether we have followed, whether this is going a robust design or not. So many times, whatever we try to do in academia, it may actually fall short of, requirements for robustness for actual, usage in the real world. So this is one lacuna that probably sometimes needs to be addressed, and these things can be done through incubation, and by, which also requires team building. And here, as Mr. Pandit was telling, I think that is a very outstanding effort on their part, and this is how they are going to play a very catalytic role, I think, in making this happen. That I think many of these half-baked technologies which have been developed in academia, how they can be brought to the real world. So I think he has already mentioned many of these, enablers. And I think, that is how, given this short time, of course, we can always, I can point out many things in detail.
But
Since time
quickly,
constraint,
I want to take one more minute of yours just to
okay,
understand. Maybe if I ask you for 3 points
yeah,
where the academia can play a more proactive role, in
Yes,
developing the manufacturing ecosystem, IP creation
exactly.
or licensing of EV
Right,
platforms, or the developing the
exactly.
entire EV ecosystem. If I want to
Yes.
understand three key roles that the academia should play or will play going ahead, I would, if you can elaborate that part 3 point wise, that will be
Okay. So once again, academia, as I'm telling you, it is not by nature, it is not geared to develop robust products which industries can readily take and implement them. So on the other hand, there are some wrong, I think erroneous expectations of industries, especially in India, to get ready-made things from academia, and that is not a very fair expectation. So what academia is good in doing is it can create new innovations which actually need to be taken forward by prospective industries, and that is I'm seeing that there is a lacuna there. Industries should also be interested in using indigenous technologies and take them to the level of maturity such that nobody else would have had these things. And then, as I told you earlier also, just like today what China is doing, they have developed so many things and they have made the whole world dependent on them. In many things it has become the manufacturing hub of the world. So we have examples right in front of us, so we have to make this happen through this proactive interest from industries, right? And which would take these things which have been developed in academia and take them further forward. So this
so.
is one thing that I feel which should happen. The only other thing that I would like to point out is that sometimes industries, because they are
Mm.
always under pressure to deliver, so they many a time do not have enough time to look at things in detail. So they should approach academia to, say, for example,
Oh,
giving an example of EV motors, right? So there are many gray areas here, because unlike in the case of IC engines, where you have only, two types of IC engines, basically a spark ignition engine, that is a petrol engine, or a compression ignition engine, which is a diesel engine. When we are talking about electric motors, there are many options actually, and which tend to be quite different from the other, each one of them. So there are, and then there are vested interests which try to push only certain technologies. So here,
okay.
academia can play a major role in doing a very detailed study. For example, a comparison between BLDC, PMSM,
Mm.
induction motor, switch reluctance, or synchronous reluctance motor. So I feel that knowledge is lacking, and we are always trying to go with whatever is being done in China or Japan or Korea or Germany, etc. We need
Okay.
to do
So
these studies ourselves, and
so
I'm telling
maybe
you that Toyota, companies
maybe we
like
have to
Toyota,
create our maybe we have to create our own model, right, Professor Dev?
and our
That may be
own
that may be the
original
thought.
study.
That may I understand that's the entire thought process that you want to bring forward. So
And I would
maybe
like
we
to
can now,
chime in here.
yeah.
At the risk of sounding like an advertisement for Prakriti,
Mm.
I would like to say that exactly what Professor mentioned is what we are doing now. So, like Professor mentioned, there's a concept that gets evolved in an academic research, but then that needs some amount of work. I mean, we and in the industry jargon, it's called DFXs, that is design for manufacturability, design for reliability, design for serviceability, and so on and so forth. So that is missing from that particular prototype. So in order for that to be included, that's a role where both industry and academia have to participate together, and that's where we bridge that gap. So the general mindset is that the industry wants a ready product to be manufactured and sold. That is not a reality. I mean, if you go to the US or even in the European region, you have MIT or a Stanford where the industry and academia work very close to each other. So that's the kind of cohesion that we need to bring in, and that's the end goal for us as FSID, where we are trying to bring in academia and industry to talk at one table, and not treat it as silos, not treat their jobs as silos.
Probably on that note, we can open the floor for questions from our participants. Uh, it will be great if you can, uh, uh, all of you, either you can type your questions or raise your hands so that we can ask questions. Anyone? Any questions that from the
I think there are
panelists?
some questions and in the
Q&A
section.
session. Let me check. Um, a question from Mr. Vinay Kulkarni. So what about the opportunities for the battery management system industry, BMS localization, and all these things? A lot of talks are going on. So Mr. Kulkarni wants to know about the opportunities in this regard. Anyone from the panelists, you can probably take it.
Yeah, I would like to answer. I will already written an answer also. So it's a good thing is considering this last 11 years of experience from the government for promoting this e-mobility, they have mandated now for battery management system has to be localized, and it's a very good opportunity for our companies, our engineering team to understand the battery pack, the safety requirements of the regulations, and they are doing, I must say, they are doing good thing like they are designing and even the manufacturing in India. So it's a good opportunity, and that same knowledge they can utilize not only for the EVs, they can utilize this BMS which is required for storage batteries also, because a lot of projects are going on. You can say containerized storage batteries. There also lithium ion batteries are being will be used in coming future. I have seen many companies are now moving for home applications like small battery pack which are required for home inverter. So those are also coming in lithium ion designs. So earlier lead acid was dominating it, but nowadays since some LFP chemistry price point has reduced, so many of the companies are exploring the batteries. So similar, so all these lithium ion technology, they need a battery management system to take care of the right functionality of the battery. So this knowledge not only in vehicle but in storage. Then another area is coming is construction equipment or could be industrial grade forklifts or towing machine. There it can be utilized. There are certain autonomous vehicles on the ports also which are running on electric, like shifting certain containers and one location to another location. There also this can be utilized. So BMS, it's a good charge. The localization mandate has forced these companies to manufacture this BMS, which has given a opportunity for designing as well as manufacturing within India. Yeah.
Another question that is there in the Q&A section is one, how can the approach to the companies to establish for center of excellence in e-mobility academic institutions, and what are the challenges that uh, that they are seeing at this point of time? Probably Mr. Akshay can take that question.
Can you repeat it for me?
how how can the approach to the companies to establish the center of excellence in e-mobility and what are the challenges?
I think no challenges per se, but I think the capex towards it, possibly the investment required, that could be, if that issue is sorted out, then I think I mean I recently I'm working with one university here in Sambhaji Nagar, BMU, that is Marathwada University. So I think the institutes, the academia sites are ready. They are taking a challenge because as I was telling that, being in a tier two, having this, quite a new segment which required a very new skill in terms of R&D product. So, we were facing a lot of challenges towards, having the team, building the team, retaining them, having Pune as a very aspirant city nearby, and that attracts everyone from the day one, right? So, last 1 year I have worked with them. We as a group, Bagla group, we have worked with them. We made a syllabus where, we are trying to, convert those, not only limiting to engineering graduates, but we started this for a BSc graduate who are the other, into science and technology. So giving them, the syllabus of, how the embedded can play the role, how the AI can play the role to their career, and they can build as it. So I think their academia possibly play a very, they have a opportunity to play a very good role. Like this city is going through a lot of industrial transformation, but of course the people will, come down here. There will be a migration of a people, but still I think the local people plays the role and local ecosystem plays the role. Excellence center, I think anyone could do it. All the building blocks are available. The organization like ARI, they always encourage. They do have one of team who can assist into it. There are other professional companies who has this complete suite to offer, but it all about boils down to the investment it required. But yes, I think our promoter is very much interested. I am working on one such project where we would have our own lab, which is enough to having a enough setup infra and that excellence where we can verify, validate, do all the component evaluation, because we intend and we are intensively working on backward integration. We have invested ourselves into power electronics, so we need that background, capabilities. Power electronics is all about how you do a component evaluation, because you have to ensure that it's not a one-time topology adoption, but you have to ensure that delivery of consistently and very much reliably across all the terrain, across all the environmental challenges. So we are working there. I think as of now, if in a bullet point, if I have to answer you, so it is only the investment which is a challenge. Uh, but of course, I mean, it has its own resolution also. So we
Okay.
we we ourselves are working on it.
Okay. Coming to Mr. Pandit, next question, maybe if you can take it up. Um, uh, one question is being raised with regards to the creating positive perception for better adoption of EV vehicles. Would like to know from you about the role with regards to creating a positive perception for the entire industry, the entire ecosystem. Maybe you can give your.
See, it's a perception of risk that way. I mean, that way even petrol is as inflammable as the lithium material, right? So it's just that we've been used to it, and once there is enough safeguards put in place, I don't see a challenge going forward. And it's that initial early stage in the teething problems that are highlighted as and when there is a fire, there's a highlight made of it, and then that creates that fear. Otherwise, I don't see a challenge there, because it's like any other technology that has been commercialized. So just to add to what Manojji and Akshayji mentioned earlier on in terms of COE, Centers of Excellence, it is very critical for the educational institutions near these clusters, industrial clusters, to become local COEs for these kind of industries, because they become the immediate go-to support systems, which can in turn be connected to larger in academia like IITs or IAC or even ARAI for that matter. So that way it creates a network of excellence in India. So that's something that we envision as part of our framework in Pravriddhi.
There's one more question on FSID's steps to reach out to larger audience in the industry. Would you or Mr.
Larger what? Sorry?
larger audience in the industry,
Audience. Okay.
audience in the industry? So one of you, either Mr. Pandit or Professor Dev, can take it.
So I'll say from FSID perspective, and then probably Professor Deb can add from Indian Institute of Science aspect. We are connecting using various mediums. One is we are connecting with all industry bodies. We are talking to ASSOCHAM, CII, FICCI and such large industry bodies to socialize the concept of product acceleration so that industry becomes aware of such opportunities that they can take advantage of. And of course, we are using LinkedIn and other social media aggressively to convey these kind of information to the industry, and we are inviting them to participate. They can always visit our website, prakriti.org, where there is a set of instructions to enroll with us, so that as and when there is some product that need to be built, and if it's there in their area of expertise, they could participate.
Professor Dev, if you want to
Good.
add.
So, in terms of IISc, I would like to add here that, I mean, we are in a very unique position where we are able to provide support to, say, all upcoming organizations, as well as even established OEMs also. In terms of, any subsystem level, say, expertise, say, for example, in terms of batteries and battery cells, like say today people are trying to develop solid electrolytes. I mean, we were talking about the safety of batteries. So from just lithium ion batteries, which were probably little more prone to, fire hazards, today we have lithium iron phosphate batteries, which are regarded as much more safe and almost like almost incident free in terms of any fire related incidents. So that way it is already a quantum leap forward. And to make things even further more safe, say, for example, in terms of impact safety of batteries. So so if we have like a semi-solid or liquid electrolyte, then these the various electrodes, especially positive and negative electrodes, they can come into contact with each other, and then that can lead to short circuiting and again fire. So this can be to a great extent mitigated if we have solid electrolytes, right? So because these electrodes would not so easily be able to come into contact with each other. But nevertheless, I would like to say that in India, again, I have found that people are only trying to assemble cells and putting together in the form of a battery, and they are looking into BMS, etc. From the electrochemistry standpoint, they are just addressing safety. But I have seen that nobody is, almost like to my best knowledge, nobody is looking into the impact safety of batteries, because when we put such large battery stacks in cars, we know that there are I mean, there are a lot of vulnerabilities for these batteries when they get impacted during accidents. So these aspects, I think, to my best knowledge, that we are being not looked into very seriously. So these are the things where, again, IISc can really provide great support. Means we have labs where we have unique, impact testing facilities, which I think cannot be found anywhere else in India, under a single, I mean, under one roof, so to say. We have a number of impact testing setups, split Hopkinson pressure bar device for high strain rate material characterization, UTMs, almost name anything. And these things are again supplemented with research in cells, chemistry, etc. Finding alternatives to lithium ions or lithium batteries, also lithium based batteries, and which would also make a big difference in our goal of achieving this self-reliance, Atmanirbhar Bharat and Vikshit Bharat, as we were saying, right? So
So
I'm very
probably the goal
so
of
all these
achieving.
things we can actually help out.
Hmm.
I mean, there is only one small thing I would like to tell here, is that India is a very perplexing country. Many a time we are assuming that we have to go to West or abroad to get things because it is not available in India. But actually, we'll be surprised how many things are already available. It's just only that we don't know. So we were talking about BMS. I have seen so many people are working on BMS, but then we don't have anything per se when we try to look for a commercial BMS. So this is only because that we are all working in chimneys, and finally we are not. And then although we say that, I mean, it is a well-known fact that we do have a plethora of regulations. I am not saying that this is not good, right? It is definitely good, but sometimes we are just tying our legs, right, with chains. That too much of regulation sometimes is not good. because we have to be optimistic. Just I would tell you, I mean, we have to be realistic rather and pragmatic. So if you
Okay,
just
got it.
permit me half a minute, I would just like to give you one example that how we suffer from lack of rationalization in India.
If you can,
So
if you
we
can give
have
it
this
quickly, that will be great.
very
So
quickly. So I
then
will
we can
just
take
tell
one more
you,
question.
I'll just tell you about these two-wheelers, right? So we are the largest probably users of two-wheelers in the world. And it is a great industry. People really love two-wheelers. But a two-wheeler is acknowledged as one of the most unsafe modes of transportation. So we also hold the dubious record of having the largest annual road fatalities by country-wise in the world. And a very disproportionately high fraction of the or high number of the fatalities, right, that are being caused. I mean, these are actually being suffered by the two-wheeler users. So there is no crash safety. There is nothing when we are talking about two-wheelers, which we are promoting in a big way, right? But when we are talking about four-wheelers, we are saying that we have to make global NCAP. Four-wheelers are already a little bit safe. I'm not against any of these things, but I'm just saying that we lack rationalization, right? So in some sense, new products, new a company, we are not having something like BYD, for example, or Tesla. I think, we have to rethink about these things a little bit. That's my only request.
Okay, thank you very much.
If you want to
And
leapfrog.
one more question we will take. Probably Mr. Desai responded to that online as well, but since we have not got into that part, would like to know for everyone you may respond, Mr. Desai. This is with regards to the discarded batteries and also the battery recycling part of it. Would If you can enlighten everyone with regards to your views on this, how this should be done, and what are the steps that the government is taking?
Yeah, so there are regulations or the gadget notification for these batteries. So mostly it will be collected by the OEMs at their dealer point, and the immediate second application might be if, because these batteries still they will be having 80% of the capacity, so it can go for storage applications. So they might rearrange it. The modules might be removed or rearranging the batteries to preparing it for storage application. That might be immediate application, because you rightly said the initial vehicles maybe another 2 years or 3 years time might reach to the end of the life of the vehicles, because we have start number of vehicles which are coming more in the last 2 and 3 years. Then after that also, for second application, there are many companies now who has established a recycling facility. So they are removing the cells, they are tearing it off, that they are taking out the material, and the material will be recycled, like lithium or cobalt will be taken out, and that urban mining they will be doing, and it will go for a new cell manufacturing. Most of the NCL and all, they have already demonstrated with recycled material creating new cells out of that. So it is in the process right now. Another 2 or 3 years time, the really end of life of the first generation vehicles will come, and you will see utilize these batteries for second application of storage, and then later for recycling the cell itself.
Okay. So, concluding the session, I would like to thank each one of you, all our participants, all our panelists. To name all the panelists, Mr. Akshaya Bargute from the Impactware Technologies GoEco, from the government side, Mr. Manoj Desai, Deputy Director of ARAI, and Professor Anindya Deb, who is from the Department of Design and Manufacturing at IISc, and Mr. Yogesh Pandit, Director of Pravriti. Thank you, each one of you, for this wonderful session, and thank you, all the participants. Thank you for all the questions and enlightening all of us, all the participants, and myself with your wonderful views with regards to the sector and its challenges ahead. I hope we all be able to provide and build a resilient, self-sufficient EV ecosystem right here in India. Thank you. Thank you very
Yeah.
much.
Thank you. Thank you very much.
Thank you. Bye-bye.
Thank you.
Thank you so
Bye.
much, everyone. Thank you.
Bye.